Okay, so today's question is the population of a city is 945,197. A new family moves to the city. What might the new population be, and how do you know?
We said the new population would be 945,200 because we searched up online what would be the average of like a family, and the average family was 3. So we added 3 to the old population and we got that as our answer.
Okay, so I'm now curious with the answer. Okay, what do you notice about the numbers in the answer? Because there a change has happened. Obviously, we're adding 3 people to our city. What set of numbers changed? We added 3 people. What changed in the answer? And explain. This is a strategy I want you to explain.
The hundreds, tens, and ones changed.
Okay. How did you know to regroup the ones, the tens, and the hundreds, and not the other ones? That's the thinking. Continue.
Because you have to start from the right. Whatever you're adding, you start from the right side, and so we did a similar thing, right? And then we start from the right, and our answer was kind of similar. So we know that if you start from the right, the other numbers might change out as well.
Okay. So 3 is a good number for there to be a change. What other number, based on a size of a family, would make this change?
5.
5 is a good number because it's common. How many of you have 5 people in your family? So that's like about a third of you. So you know that a family is going to usually be less than 10 people, usually. Okay? What number would not make this question work? What would make this number not give the results that I was looking for, at least as a teacher?
1.
Definitely a family of 1 won't help. And there's another answer I'm looking for. What else would not make this work, and why won't it make it work? Tahir. Why won't 2 work either?
Because 2 is a couple.
2 is a couple. You're right. It still can technically be a family. Okay? But in this situation, 2 won't work. Why?
Because you're not really changing anything in the other column. You're just going to add 2 to 7, that would be just 9, and then you're not really changing anything.
Right, because we're regrouping the numbers now. Okay? Because the largest number that you're going to have to deal with is what in this situation? What's the biggest number here? Out of all the numbers that you see, what's the biggest number that you'll have to deal with? 9. Why do we say 9 is the biggest number you will ever have to deal with? There's a reason why Taha said that, and not because I told him last year, or he figured it out last year, but there's a reason why 9 is the largest number you have to deal with. Why is that? Kira.
You can't add, like, in a base value format, you can't add more than 9. You can't do 10 in one column.
Can't do it. You can't do it. In each place value line, or column, 9 is the largest number. Okay? Yes?
And it's also like you say 1, 10, 100, 1 million, they're all the same. So like.
And that is the next part of the learning. You've actually snuck into the next question. Do you notice here how it's broken up? Like when I wrote the number down here, if we go back to the question here, I'll leave your book here. How is this, see how the number is separated? Over here. This number right here, look how I separated this number. Or look how it was separated. Do you notice something that might help you?
Separated in the middle.
Well, it is separated in the middle, so they're grouped in groups of what? What does it appear that they're in groups of what?
Thousands and hundreds.
Okay, well, where's the thousands?
On the left.
This is thousands. And what did you call this side here?
Hundreds.
Hundreds? This is actually called the ones. Okay? So, what place value is this? This one? Hundreds. Okay? What place value is this? How many thousands? Huh? What about this one? And what about this one? So let's get rid of the word thousands right now, and we know that the word ones, we never use it. So you're gonna tell me what place value this is, and then what place value these are. Are you ready? What's this one? Ones. What's this? Pattern, anybody? Right? So what if I added 3 more here? What would they be? So if I added 3 more numbers here, let's add 2, 1, 3. So what group would this be? Does anyone know what group this would be? And now we're really going into the next question, but that's okay, yeah. Here, millions, right? So this is millions. And then this is, again, let's do it as a class. This is the 10 million, 100 millions. So now let's drop the word millions. So now we're going to drop the word millions. We're going to drop the word thousands. We're going to drop the word ones. Are you ready? I know this seems like a very primary thing to do, but there's a reason why we're doing this. You ready? Let's do this as a little fun little activity. You ready? Let's go.
Ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds.
Done. So now there's the pattern. It repeats itself. No matter what number you have here, doesn't matter how big the number is, how small the number is, it all falls within a pattern. Okay? And this leads us to our next question. So we're going to assume the same population size. Let me write that down, 945. So that number would be read 945,197. Here is your next question. You guys work on it, okay? It's a little bit different, okay? But I want you to highlight your strategies. I also want you guys to tell me what kind of thinking you guys did. How did you come up with this? So if one person wants to record some of the conversations on Jot Notes, that would be perfect, because that's what I want to hear when we come back. So you guys will have give you a few minutes, 15, 20 minutes, whatever you need, but I encourage you all to be involved in the conversation. Okay, so part 2 of the lesson today was the town of Maple is going to join this city. So remember, the city's population, 945,197. What will the new population be? Who would like to share their information with us? You come on up. And remember, when they're sharing, okay, see what they did, how they changed it, and I want to see if you guys did the same thing. Okay? So go in order.
So first, what we did, we searched up online what the population of Maple was. It kept saying the population of Vaughan, which was like 319,883, something like that. So what we did, and it also said that there was it was made up of 5 different cities. There are 5 different cities in Vaughan. So what we did, we made an estimate by taking that 319,983. That number was something like that, and we divided that by 5, and the number that we got, it was 63,979, or it was 978.6. So we just rounded it to this. But then after that, since we don't know since it wasn't telling us the exact population, we just rounded this number, 979, to 64,000. So 63,979 to 64,000. Like it was, and then from there it made it easier to add 945,197, which was the population of the city, and then 64,000, which we thought that would be the population of Maple. And then when you add those two together, you'd get 1,009,197.
Okay. I like how this group shared their thinking. But this number here, how friendly is this number to you guys right now? the answer. And be honest. Is this a very friendly number for us to deal with? Okay. What makes this number not friendly? Ali.
It's a 7 because in the first part we did like 945,197
Yeah. Yeah.
and add the family,
Yeah.
which was about 3 or 4,
Yeah.
and then you would get a different answer.
Okay.
So, but this group didn't add it.
Okay. I think I understand what you're saying, but there's a difference between adding one family and a whole city. True or false? Is it easier to get an accurate number for one family over an entire city? What do you guys think? The family is easier to get an accurate number. Now, a city or a town like Maple, you cannot get an accurate number. It becomes a little more difficult. Even though the population here is relatively accurate, okay, we didn't know exactly how many people live in Maple. 893 is the approximate population of Vaughan. How many towns are in Vaughan? There's 5 towns. So if there's 5 towns, what did you guys do in this situation? Sophia? Now, you divided 319, 893 by 5. Is there another number you could have divided by just to start this all off? That's my question. Because you guys did all this and then made a couple changes in the middle. What could you have done maybe early on to make it a little bit more manageable? Jaleese, what would you round this to? Give me a number. Anybody?
320,000.
320,000 is a good one. Why 320,000 and not, say, 319, 890 or 319, 900? Why would you choose this one over those two?
Because it's also easier to divide it, and it's less complicated.
Right. Remember the last 2 lessons, making numbers manageable? We're now entering a different area. We're estimating. And if you're going to estimate, when we estimated the size of a family, we said 4, 5. But we agreed that it would be less than 10. When you're estimating the size of a city, rounding it to the nearest 10 or 5, it's not a good idea. Why isn't it a good idea to round to the nearest 10 when you're talking about a population of a city?
Because the population of a city is normally really big, right? And 10 or like 5 is a really small number, so it wouldn't make a big difference. But if you round to like 1,000 or something, that would make it even more easier.
It makes it easier. You're absolutely right, because the numbers are larger. And in this situation, we don't know the population of Maple. We are unable to find it. So the strategy you guys used, very smart. Get the population of Vaughan, divide it by the number of towns in Vaughan. That gives you about how many people are in Maple. So for some of you who gave me this number here, and you added it directly into the city, why is it wrong to do that? Or why is it not the best approach? I think it's wrong to do that. Why is this not the best approach? Taking this number, which would be this answer, divided by 5 would give you this. Why is this not right to do, or not the best idea?
You don't know the exact number of the Maple population,
Right.
so you might as well just round it up just to make it easier.
Exactly. And you know what? Vaughan, by dividing it by 5, you are assuming that Vaughan is divided equally into 5 parts. Guess what? It's not equally divided. So even at 64,000, that is a little risky number to use. Okay? Is there another number you could have used for Maple's population instead of 64,000?
65,000.
65 is a good number. I was thinking a little different, but only because I have background knowledge, because I've worked here for so long. I would have chosen a different number.
60,000.
60,000 would have been my choice, because I know Maple is smaller than those other towns. I already know this. But regardless, 64,000 is a good number. For those of you who use 60,000, that's a good number too. But I just know that because I'm an old guy. So now to add a number like 64,000, is there something else you could have done to make adding these numbers easier? Because you're already estimating one town, what could you have done just to make it a little bit easier? Remember, we're trying to make numbers manageable.
We could have estimated the other town too because
Give me a good number to estimate the city's population. Just give me, sorry?
not one, right? The other one.
Yeah, the other one.
900,000. Okay.
Give me a good estimate. Ali, try, help her out.
945,000.
Yeah, 945,000. In this situation, it's okay to manipulate the numbers. We already have an estimation, right? So then, and if you were to add it by 64,000 or 60,000, then you're getting your numbers. And then you got a 9, a 0, and 10. Okay? So there you have that. Now my question to you is, what numbers changed in this question? Remember the numbers that changed in the previous question. Now what's changed? Which set of numbers changed?
1,000 to 10,000.
You get the thousands, the 10,000s, and the 100,000s, and it gave birth to a new number for us in this situation, which is what column? Millions. Again, what you did for the first question here, what you did for this one here, you played with these numbers here. Remember, you added, say, 4 people. You just dealt with this side here, and you didn't touch that. Now it's going the opposite. You're basically messing around with this, and the result is almost the same. Okay, and then you can say you can have a population of 1,900,000, or sorry, 1,009,000. However, when you answer a question like this, because you're estimating, you can say the population is about or approximately. You can't say the population is, because it's not that number. In this case, it's an approximate, and that's what I was trying to guide in your discussion.